So I guess we need to do this one in English, don't we?
I guess so. Our first episode in English. Hi, Stefan.
Hey, Vladо, I don't know if you remember, but in the first episode we discussed why are we not doing it in English. And I said this because we sound like the famous Bulgarian football player Hristos Stoichkov.
Oh, we are not that good.
We're not that good.
We're not that good, man.
Now is going to be an opportunity to show this,
Yes.
to demonstrate what I meant, because we have a, non-Bulgarian guest.
He's more Bulgarian compared to a lot of other Bulgarians. Like, he's true Bulgarian. He's not from Sofia. So, like, real Bulgarians, they don't live in Sofia. Because, the real patriots, they live in the countryside. And Can we dox the place where you live?
I live in Pleven. I think it's important for the listeners to know this. Yeah, they should know exactly who I am.
Yeah. So he's in Pleven, the most glorious city in Bulgaria, where the famous battle between the Russian Empire and the Ottoman Empire happened during the Liberation War. Right?
Shipka Pass is probably what you're referring to. Yeah.
The Shipka Pass happened, but at the same time there was this siege of Pleven. So the Ottoman Empire troops tried to cross the mountains via the Shipka Pass to reach Pleven and break the siege, which the Russian Empire laid against the city. It was not successful crossing, and the city fell, and Bulgaria is free. And that's why you have this in Pleven, that huge monument on top of the hill.
Right,
commemorating that. But we are not here. This is not the history podcast of Bulgaria. This is development podcast, a programming podcast. But first of all, we would really like to thank to all of our listeners. Me and Stefan, we are very proud that a lot of people find this podcast very useful. We want to remind you that we have a store with t-shirts, and Stefan will knock right now. But Vladо, we don't have stickers, etc. We will.
Oh, wait, remember now. We are airing this in 2024, and you've promised that there are going to be stickers.
I am.
So I expect that when people hear this, there are going to be stickers.
Yes, Stefan creates this narrative for me that I forget things, which is not the case. I'm a bloody manager, so I have this historical memory for things. I don't rely only on ticketing systems to remember things. So we will have stickers, but we have t-shirts now, and that's the perfect time to buy one of them. What else we would like to say? We have a feedback form. Go to the notes of the podcast, fill that form if you didn't fill it. We have a Discord server. That Discord server is booming. I just had a conversation about fitness in the podcast section. I'm sure that Stefan will be really angry because of that. But I really like creating off topics. But Stefan, do you have any comments on that?
Are we done with thumping our own horn, Vladо, or can we move on?
Beating around the bush. Yeah, let's move on. Let's introduce our guest. Hi, Rickard.
Hello.
How are you?
I'm good. I'm always good.
You're always good. Apart from being based in Pleven, what can you tell us about yourself?
Well, started programming a long time ago.
What is long time ago?
It's back in the old days of ADSL.
Oh, man.
And when IRC was a thing and so on. I'm that old. If someone doesn't know what IRC is, yes, I'm that old. This was an actual thing. Most of us were doing it.
I found my wife in IRC, by the way. That's a real story in 2001. Yeah, so I really love our IRC. And I believe that a lot of our listeners, they use IRC. By saying that you used IRC, a lot of people, I believe they still use IRC, right? And that's...
Well, define a lot of people, right? I think that's where
50.
That's kind of... I think a reasonably sized channel, that has, some legacy to it, let's say, right? Has maybe a few hundred users at the moment, right? So it's fallen off significantly is what I would say. Not that actually reflects the medium itself, to be honest, right? Most of these types of scenarios don't. So just to be clear, I started programming back in 2001.
Impressive. You look younger, by the way.
Fair enough. Thank you, I guess.
Programming preserved you well.
Oh, well. No, I would guess the few. For those who are listening to this, I do not have any hair, and that's most certainly because of programming.
Because you pull out your hair a lot.
Yeah, exactly.
Do you do that?
many hours have been spent debugging and losing hair over many things. So yeah, that's the situation, probably more than anything. But no, yeah, back in 2001, which I guess is my most defining characteristic as a person, which either makes me extremely boring or interesting to a person, is what I would guess. Because what I am at my core is a programmer, right? That is just who I am. That is what I enjoy doing. My free time, I program, or I do research on stuff, basically. In my work time, I do programming, or I do research on stuff, basically. So that is my life, right?
Do you contribute on any open source project or free and open source project? This is what people do in their free time when they develop, or...
Right. No, I think that's for ambitious people with good career-making skills, I would say. And I would say I've never focused on career-making skills, but I have sort of stumbled into a great career, is how I would say it. Like I've fallen into the pit of success by accident, mostly, by just sort of...
Or by luck.
Yeah, I mean, it is luck, I would say, generally speaking. I mean, it requires a certain exploratory mind, you could say, an inquisitive mind to some degree. I have by chance sort of, let's say, been 5 or 6 years before the curve a lot of time, right? So things that end up becoming popular, I'm already there, right? Some of them I don't actually stay in. So back in 2016, 2017, I was very much into Rust, for example.
Can you share more details about that? So how did you start in 2001? With what attracted you in programming? Like, was it your parents, or you were, I don't know, in love with a project? I don't know. Like, share more and tell us more. How did you transform this into the career you just mentioned?
Right. Yeah. So I started back in 2001 by asking the simple question, what do I need to do in order to become a hacker?
A hacker?
Yeah, that's what I wanted to do. I wanted to break into people's things. And
this is not a joke.
Spelunk there, right?
Okay.
Basically. Never for the purposes of actually, doing, thievery or anything like this. I was interested in the idea of breaking into people's systems. That's what I wanted to do, right?
Okay.
So I asked a person on IRC, in fact, random person. He didn't know anything about hacking as far as I know. But I sort of was just talking about it, right, on IRC. And he said, well, if you want to be a hacker and not some fucking script kiddie, is how he said it, then you're going to have to learn programming.
Yeah.
Right. And I was like, okay, fair enough. How do you learn programming then? And he said, well, I don't know. Here's some languages that people use, I think, or whatever. Right. For all I know, he could have been a programmer himself, but he just didn't want to engage in this conversation in that kind of way. Right. Yeah. But I end up basically catching the scent of a language called C++, right, to my future demise. Right. Yeah. But so basically, I find C++, and I find this entirely new world where hacking is just not what I want to do anymore, because it's fundamentally not that interesting in comparison to making things, right? Because I got into it just because, you need to know about, because back then honestly, hacking was the dumbest stuff ever. Like, it was, you literally go find the source code, which, to be fair, was kind of difficult sometimes, right?
Yeah.
But you find the source code to some software, and you find that, there's a trivial buffer overflow here.
Yeah. Because
people are fucking dumb as fuck, right? They don't have any concept at all at this time of what is security. And this was, honestly, this continued because I kept track of some stuff, you find source code here and there and so on. You find out which exploits are actually being used. Yeah. And honestly, this continued for some time. Like, people were just oblivious to the idea that a buffer overflow was even stuff that would end up, pooling you, right? Or owning you, right? So it was very much, I went from that sort of looking at those things specifically to just saying, well, I mean, I kind of feel like making stuff is more interesting.
So you're a builder, you're not a destroyer.
Yeah. I found kind of my true self in trying to sort of say, okay, how do I take something apart to effectively do something destructive.
Yeah.
And say, no, I actually feel like this is my creative outlet instead, right? And so that was sort of how that developed, right? And after that point, it was really like, I wasn't interested anymore in the other stuff. I mean, of course, it came up. Everyone needs to be security conscious, right? Especially if you're writing C++ back in the early 2000s. Like I said, I think we were in some ways still discovering exactly how dumb we could be, and I say that about everyone in programming at the time, to be honest, right?
Were you successful in your hacking career?
No, I wouldn't say that I was. Yeah. I mean, define success, but
I don't know. It's up to you. It's a very subjective term, so.
Yeah, no, I would say no. Let's leave it at this.
Okay.
Things have been done, but those things I'm not entirely sure we should dredge up. But
the dark past of Rickard.
Yeah, I would say I got a concept of what a lot of things, mean, and some of those things turned out to be practically useful and so on. In the end, I think the hacking thing was really it was a useful vehicle for learning why things are done the way they are done when they are done correctly.
Yeah.
Right. Meaning, I think I only really learned about salting, hashed passwords because I was cracking passwords from databases.
Yeah.
And it was ridiculously easy, right? And so adding salts to those actually became it's a critical difference between me seeing your password. I have this database dump, right? Yeah. And not seeing that because I don't know the salt or, this has been hashed 10 times or whatever, right?
Yeah.
So these kinds of things get put in a completely different context, right? Where this is the difference between me seeing this poor person's password, right? And that's where also like these, character limits come in, right? And so on. And all of that evolves in tandem, right? So do you know what rainbow tables are? Right. Okay. So this evolved alongside this idea of, wow, we have enough storage to actually store pre-computed hashes of a bunch of different, a whole data set, right? And now it becomes yet easier to actually see these passwords, even though we might have like, oh, hang on, we weren't supposed to be able to do this, right? Even with some of the mitigations that people had, now we're able to see them and so on. So I think all of this evolved kind of in tandem, right? And through that lens, it's a very useful learning vehicle, like, because I don't want to be the guy with the database that someone is looking at, right? That's the more important part, let's say, of that situation, right? The actual doing of this and finding someone's password and so on can only really, like, if you have any kind of empathy in you, you will realize, hey, this is wrong. Like, this person specifically did not do anything wrong in this situation. They registered on the wrong website, right?
Yeah.
And so on. And I think if I did not have that conscience, maybe I would have gone the other way, maybe. But
So but you got that conscious and you moved away from that path and you stayed in the builder's path. So how that path evolved for you?
Well, it's interesting because basically from the years, let's say 2001 when I started to 2014 or so, I was adamant that I did not want to work with programming, right? And this was, in part, it was, speculation. In part, it was informed by looking at some of the programmers that I knew and saying, that does not seem so fun. That doesn't seem like what I want to do, right? Because at this point, remember, I got in it for entirely my own reasons from the beginning, right? It wasn't connected to a career. It wasn't connected to anything like this, right? And then it became, I just like making things. And I like making the things that I like to make, right? And so on. And so at this point, I probably had some level of like, this cannot possibly be the same when you do it for money, for other people. And I'll say this, I was partly right. It's considerably worse writing code for other people. I think this at least, right? However, it's probably better than anything else that I can do in life. And that's, the unfortunate reality is everything else sucks probably more, right? When you, work for other people, I would say, or even work for yourself. Like if it's work, it's work, And so I think I realized at some point I would rather maybe program for money, and then I still have my free time and I can do the things that I kind of like, right?
Yeah. What do you like? What do you do in your free time when you use programming?
In practice, I would say mostly make things that no one asked for because I want to and I want to learn something. That's kind of the sort of golden nugget in everything is really, I actually added some knowledge here, right? And that's also something that I think is sometimes, I think, threatened by a career, to be honest, right? And what I mean by that is, I think this might just be my observation. Obviously, I'm just one data point here. But I see a lot of people who seem to effectively only do programming at work, and they don't necessarily learn that much at work, and they don't really learn much at all. And that, I think, is dangerous for a mind a little bit to some degree. Also for a career, maybe in the long run. I'm not sure, really. Because these are people who are doing well, and I don't necessarily think they need to sort of, hey, you need to pump up your career. These are rookie numbers. That's not really what I'm thinking, right? But I think it can be dangerous for the mind a little bit to fall into this complacent
in a way. They settle and they stay in their comfortable zone. So that's
I think, and this is a mentality that I think we all fall into sometimes, right? So I've literally uttered the words, and this, I was particularly angry at the time, so I'm going to just sort of excuse it by saying that. Actually, I guess I can tell you more about that scenario.
Please do.
I have at one point literally said the words, I know X many languages, I don't need to learn more right now. That was a very ignorant comment to make, and I made this comment at a company called Crytek. And the situation we were in Crytek at the time was we were not getting paid. We hadn't gotten paid for 2 months.
Oh.
And I said this to someone who said, why don't you just sit down and learn something? Because they had made peace with the fact that we didn't get paid. Probably because they were making more than me, right, at the time. And they felt comfortable sitting doing nothing, effectively. Or, learning something, perhaps, right? For context, this was someone on, I think, the engine team. And I'm in the back-end team at Crytek at the time. And so on. And, this kind of scenario, right? Of course, I said that because I was angry, in part because literally no one seemed to care at the company, which was a strange attitude for me, because I'm sitting there feeling like, something has to be done, right? We can't just not be paid for 2 months and so on and so forth, right? But that was the context for that comment. And I think that sentiment is actually real, though.
Sorry for interrupting, but this company, that's the company which is responsible for Crisis,
yes.
Right? Far Cry?
Yeah. If this is the first you're hearing of Crytek not paying their people, I can tell you it's happened at least 2 times, maybe 3.
This is a major studio, one of the most advanced one.
I will say one thing that probably tells the story better than unless just telling the actual story. They used to have studios in Shanghai, in Ukraine, and in Bulgaria. Key phrase being used to have.
Yeah.
But sometimes when you can't pay your people, you have to actually sell 3 or 4 studios around the world and then develop a cryptocurrency called CryCash, because you don't know how to run a company. So sometimes stuff happens, right?
Yeah, the Bulgarian
I guess my feelings on Crytek are clear.
The Bulgarian studio, they sold to Sega in 2017.
Yes. Yeah. I was part of. I was being sold as part of.
I'm just reading Wikipedia.
Yeah. So basically, I guess this was in 2017 or early 2018. It was actually the shift between them. I think we became Creative Assembly, CA Sofia or Sega Black Sea, depending on who you're talking to. If you're talking to a Sega executive, probably you say Sega Black Sea. For everyone else, you're probably saying Creative Assembly Sofia or CA Sofia. Yeah.
Okay.
But so I worked on the back-end team there. Yeah. And to go back to the actual original thing, the sentiment here was, I know enough, right? And regardless of the context of where you say this, right, you're not correct, right? There's no situation in which you are correct when you say this, right? The sad truth to some is that we never know enough, right? And that is, you can either face that by just being a realist and saying, well, I can learn a little bit at a time and, be a normal kind of productive person, or you can shut down completely and say, no, I'm here and I refuse to go further, right? And sometimes that might be the correct, in a localized section of the industry, you might say JavaScript frameworks, for example, it might be time at some point to say, enough is enough. I'm staying where I am.
For the benefit of our listeners, just mention a few of the languages that you worked with or that you can say that you can work with right now? And is there a preferred language like Ruby for Stefan? But yeah.
Right. Yeah. So I started with C++. If someone came to me and asked me would I work with that, I would say no. I then went to Python.
Okay.
If someone asked me if I would want to work with that, I would definitely say no. It's a hard no on that one. And then I used a language called Racket, which I do love, but I don't know that it's appropriate for real projects, to be honest. That's in part because I have a certain skew towards static typing, strong typing, and so on. Then I went over to Elixir, which actually is where I actually built the useful part of my career, is what I would say. This is the part where I actually left behind this idea of not working, for example, for money and so on. And I wanted to actually work with making backends in Elixir and so on. And I had made plenty of backends in C++, Python, and so on before. But this was basically a step that took it into, let's say, a professional context. And I would say a little bit of a different world where it was more deliberately thinking about distributed systems and so on. So Erlang and Elixir. Erlang is what we used at Sega and at Crytek and Sega / Creative Assembly.
I just want to give kudos to Valentin, who we already recorded an episode with him. It was focused on Elixir and a little bit of Erlang. And we would like to say thanks to Valentin for connecting us with you. So that's why you're here with us today. Sorry for interrupting, but I feel that this is the right moment to say thanks to Valentin. Yeah.
No, I'm also thankful for Valentin actually putting this together because it's fun. It's interesting, right? Mm-hmm. And so indeed, I was, for example, in a team actually on a later contract with Valentin, and we got to know each other there and so on. And Elixir also suffers from a lack of, let's say, static typing, which is where stuff kind of ground to a halt for me with regards to sort of, can I actually say that this is, will this actually suffice at some point, right? And that's a feeling where, some listeners are probably hearing that and saying, this guy is some kind of fundamentalist, whatever, right? What I mean by suffice is like, can it suffice for me in the long run in a big project where I don't remember everything? I think establishing your own abilities and knowing the limits of those can be very useful, right? I know my own abilities and sort of what I can remember, what I can keep in my head and so on, generally speaking. It's been a long time, I have some sense of what, goes on in there, right? And I don't think I can handle a dynamic language, beyond a certain amount of, let's say, transformations, lines of code, whatever metric you have that describes complexity. There's a limit there where I will just sort of start falling apart, right? I know this about myself. And if nothing else, there's a morale kind of hit where you suffer enough annoying type errors that happen when you run code instead of before, right? That morale hit just keeps gnawing at you, right? This is obviously I'm describing this in a very dramatic way, but this is exactly how it feels, right? Oh, of course, yeah. We changed this to some other shit, and now I have to deal with this, right? I have to deal with this not before, right, when I made the change, but now when the code is being run. And that's fundamentally just a very taxing concept for me. It becomes very difficult. You're walking through snow in some ways when this happens, I feel, And this is sort of shaped maybe how I feel about some of these things, where I absolutely love the threading model of Erlang and the virtual machine, right? I love how it works. I love how it scales. I love the trade-offs they've made, right? Average latency across many 100,000 clients in Erlang is low, right? Is the absolute latency of one of these clients the lowest it can be? No, not really. But we can have it across many, many clients, right? So for building real live systems where, let's say 100,000 people need to know about the same things at approximately the same time, this is a very good VM to do it on, right? It's just that the languages that I have at my disposal have not historically been the ones that I want to use in the long run. And that's where it falls apart to me, maybe. So obviously, those who are astute will understand that I wanted something, that could give me more guarantees before the code is run, right? So we go to Haskell, obviously, as you do when you have nothing better to do.
Famous last words.
Yeah. So I delved into, I've actually, this is a little bit of an oversimplification, right? So I actually looked at the Haskell 3 separate times before it kind of stuck. And this is I would say the typical Haskell experience is, oh, what is this? I don't get it. Okay, so I'm looking into this thing again, and I still don't get it. And of course, someone much smarter than me could have probably just gotten it the first time. But it took me 3 tries to get into Haskell, right? Sort of using it effectively and so on. And I'll be honest, some of the key things that actually happened were just basic stuff like, no, it's fine to mutate values, to be honest. To architect your application in such a way where we have, a bag of handles that basically in some ways looks like the kind of thing you would get marks on if you did it in a C course. Like, hey, we have global state here. This is potentially pretty bad, what you're doing. You probably shouldn't have this global state, and so on. And if you look into industrial Haskell, right, you find this is effectively kind of what people are doing. And if you look elsewhere in the world, you'll find that, to be honest, what is a database? It's just a bag on another computer with mutable state. We're doing this all over the place. So in some ways, taking Haskell and sort of making it more like everything else, honestly, made it click a lot more for me, because it's sort of just, it's really it's a fine imperative language, to be honest, Haskell. It's much better than people think, that is what I'll say, at least. There are certain things that don't make sense to me in the ecosystem and so on. But yeah, it's a good language. It's unfortunate. I mean, it strikes me as interesting that every language that I've talked about that I got into, I have also said, oh, but I probably wouldn't want to work in it again. Haskell is in some ways that situation, to be honest. But it's more informed by, let's say, what I think people need in software development. And I think Haskell does a lot of stuff that you don't necessarily need. And I'm not sure we should have that deeper conversation about what does Haskell have that it doesn't need and so on. But
we should definitely have that conversation. What does Haskell have that it doesn't need?
Yeah, okay. I'll pick out a few key things. Effects in types, right? And this actually includes every other language that is doing like algebraic effects or whatever. They have effects in their types, right? They're saying basically, oh, this is effectful and so on. You can do this at different resolutions, right? So you can say this is doing specifically these effects, right? Haskell has this amazing ability to actually say like, no, this function can literally only write these types of database values and so on. This is neat, absolutely. And I do think it's a superpower to some extent. You can see in your types exactly what a function can do and what it cannot do, right, by omission. But effects as types solves a problem that I'm not sure anyone is actually having. At the basic level, it's all well, and good to sort of bring up this idea. Well, when the junior is doing network stuff in the validation function, that's bad. Yes, but have we found a single junior that is doing network stuff in a validation function? That is actually my question, right? Because I'm not sure the scenario exists, right? I am 100%, like I have used these things. I have been super into them. But at some point, there comes a time when you have to evaluate, like, is this reality though, right? Is this actually something that happens? Because that scenario, like, oh, we shouldn't be able to do, modify pointers in a validation function. I'm not sure people are, I'm not sure. Most people at this point in time probably would write a pure function, even though they didn't have effects in their types. They're writing a validation function. They're not interested in talking to the network here or reading and writing from disk. That's not really on the table for them. And I think it's a disservice to juniors to say like, well, the juniors would, but why though? I don't know that this junior exists. I think we want that person to exist because we're like, juniors, but I don't think it's real, And so that's something where Haskell sort of, it sounds great in theory, but maybe practically speaking, we just don't need it. And that doesn't mean Haskell is wrong or whatever as a whole, but I believe maybe this trade-off is not the correct one for most people in most situations,
Fair enough. And where did you go after Haskell?
I got considerably burnt out on Haskell at some point in 2019. This was also at the same time there was a movement called Simple Haskell And I think a lot of us felt in some ways the same way. Simple Haskell basically said, let's not use most of the language, actually. I mean, I'm paraphrasing here. I took it to mean basically, yeah, we can use lenses, we can use template Haskell and all of these things. These are advanced facilities for doing interesting things in mostly, effective ways. But they also add a lot of annoying complexity to a project sometimes, right? And this kind of thing is sort of like saying, let's take this particular subset of Haskell and codify it to say, like, this is the stuff we use. Everyone else can use other stuff. Let's just use these things and we will have better lives. That's the premise, right? And I believe in that premise so much that I said, well, hang on a minute. What if I just say, I'm not going to use Haskell. Instead, I'm going to use something else, right? I was craving some kind of simplicity in life, right? Something that said, you don't need to learn so much more about the language, for example, about the ecosystem, about how stuff is done in the ecosystem, for example, right? What you can concentrate on learning could be just, much broader concepts. Because there's an endless amount of learning you can do in Haskell about simple things like, how do you do error handling? I've spent probably, total amount, probably days researching error handling in Haskell. And broadly speaking, I don't think it should be that way. And I think that was sort of a catalyst for me looking, maybe going to the, let's say, extreme in some other ways, right? Saying, okay, radical simplicity. What do we need in order to do things? In order to do them in a good way? And I landed on Zig. This was back in 2019. And Zig represented basically this language that you could actually, it was finite, right? First of all, community was very young. There isn't enough code out there for anyone to have any kind of like, there are 50 million ways to do error handling. Welcome, And also the design of the language doesn't necessarily permit 50 million ways to do error handling, right? It's a finite kind of thing, right? I think Zig at the time, at least, I don't know about now, but at the time it was a weekend language is what I like to call it. For a certain type of person, this language can be picked up and you can be reasonably productive after a weekend. And that was a big draw. I found this language. I think I actually found it before the weekend and I was hooked on Sunday. I had already written some programs in it. And this came with, I think, a lot of these reevaluations I had done before that were already kind of, underway or they were finished in some ways, where thinking about what is it actually that I want? What do I actually value in the process of making software and so on? And Zig hit a lot of those points. Some of them are more well-informed now, I would say, but they're on the same track. I definitely am on the same track as I was back in 2019 when I found Zig. Because I don't necessarily believe, broadly speaking, that people, let's say this, I disagree with what people think is important in software development. I'm not going to say that, I don't think they know what is important. That's obviously false. I don't hold the answers in this situation, but I disagree with most of what people think is important in software development, certainly. Just to, at risk of sounding here like, I'm painting a straw man that I'm then going to defeat, I'll state this up front so that people kind of understand what I mean. I get the sense that a lot of people think that writing the code is the important bit. And making that easier is going to pay off the most. And I don't believe that's true, which leads to certain, let's say, biases, right? So when someone talks about metaprogramming, generally speaking, I will say, I think we're solving the wrong problem because that is fundamentally this is about writing the code, and I don't think that's the important part. Metaprogramming, generally speaking, in many ecosystems at the very least, complicates debugging, the understanding of what am I looking at even.
Please explain for me what is metaprogramming.
Right, so metaprogramming, if you have to kind of generalize, is essentially the process of, let's say, using the language to influence how the language behaves. So you can, for example, let's say you invented a new keyword because your language permits doing this. You could effectively invent a new syntax for the language. You could invent a new keyword that behaves a certain way. And this comes with certain downsides, right? The most obvious one that everyone says is, now you have your own language, so everyone has to learn your language when they show up in your code base. Right? Yeah. And that's true to some extent. But more than anything, even the person that, wrote this or who has been on the team for some time will usually have a harder time just saying, hey, what am I actually looking at? Because most metaprogramming will be of the nature that sort of it expands into other syntax, for example, in the case of macros, like macro systems like Scheme or Elixir will basically have syntax that expands to functions or other constructs and so on, right? So the code you're looking at is not actually what's going to happen, right? So we have a mismatch all of a sudden. That complicates debugging because, well, what we're looking at is not what we're getting. We have to actually expand the macro to understand what's going on. In some case, we have to debug the macro because maybe the macro is wrong, and so on and so forth, right? And so those types of facilities, right? Yeah, writing the code was sometimes easier, right? Because sometimes writing the macro is actually considerably harder than the actual, problem. And we are complicating the part where I think we are the most vulnerable debugging things, right? Stuff is already at this point, something is bad. I've had to sit down and actually look at this and say, like, what is happening? I'm already in a vulnerable position at this point, right? I'm looking for a problem, right? And we have complicated that problem by layering things that only helped us when we wrote the stuff. And I don't necessarily believe that they help, generally speaking, to maintain code either, to be honest, right? Because maintaining the code over time, adding features, removing them, and so on, when you complicate certain processes, right, with, for example, macros or, over abstracting via functions and all stuff like this, you tend to make the code harder to change as well. You're basically baking it into, it's like a pierogi now of different layers with stuff and so on. The actual stuff that's happening is inside, but we've put all this stuff around it, right? And so in this situation, I don't know, my estimation is we're solving the wrong problem with the metaprogramming and the stuff like this, or overly advanced ways to define functions, for example, right? Or rules about programming that have nothing to do with actual programming, basically, right? Like, a method should only be this long, or stuff like this, right? So a lot of the principles in programming are actually destructive to understanding what's going on, unless you're kind of part of the club or whatever it might be, right? I kind of forgot here now. Why did I end up here? Right. Reevaluating my priorities when it came to programming, Zig basically fulfilling those priorities fairly well. Because Zig basically represented this world where the language is finite. There's not that much in it. You can learn it fairly fast, and then you can focus on actually implementing the solution to the problem. And a lot of people will look at that and say, well, Rickard, you need an advanced language to solve advanced problems or complex problems in a simple way. And I think, again, this is a misunderstanding of what the problem usually is. Because the advanced languages and so on, usually what is implied in my experience is we need something like metaprogramming. We need macros here to describe the problem in a simple way. But it's usually just a short way or a way that looks vaguely like something else. Like, how do we express routing in a web server? It should probably have, in some ways, like a table structure, kinda-ish, or something where we have on the left, we have routes, and on the right side, we have this, and so on. But that doesn't actually do anything for you to understand the code necessarily, like what's actually going to happen in the machine. Fundamentally, it's not very connected to in the reality of what is actually happening when the router actually, matches a route, for example, right? So I think it's a fake kind of simplicity a lot of the time, this type of thing, where this just looks short. Yes, I agree with you. It looks short and neat in some ways, right? But I don't know that it's necessarily simple, right? Because it involves actual metaprogramming and so on. I think a great example of this, and I might irk someone a little bit here, Valentin, for example, probably would be upset with me to say this, but a great example of fake simplicity is Phoenix, the Elixir web framework. If you look at a router in Phoenix, it is a collection of macros that do things that no one could have any hope of understanding what they do unless they look deeply into each of them, effectively. They can understand the semantics of what's trying to be expressed, right? And I think that's the fallback is for the type of people who think this is how we do it, the fallback is, well, it looks fine to someone who understands, what a router does, right? So these router modules, right? And yeah, I agree. But when it comes to the maintenance of software and changing it and so on, I'm not concerned necessarily only with the semantics, right? What do you mean by this code? I'm concerned with what's actually happening. What transformations are we doing to end up where? Data comes in, it's A, right? We go to B, we go to C, we go to eventually Z, right, at the end, somewhere, right? The data transformations in a program is the only thing I'm concerned with, because it's the only thing that's real in the end. Every program is a series of transformations from one form to another in order to accomplish an end result. Sometimes the end result is a number that is put in a register, and then you do syscall. But fundamentally, there's a transformation somewhere happening. But this is mostly, it's most pronounced in systems that are architected this way also, like graphics cards and so on. We get memory from the graphics card. We put, geometry and stuff in basically a buffer. And then we say, take this buffer and render it. Fundamentally, everything that happens in this game engine is about transformations that end up being either visible or their data in audio, their packets on the network, and so on. Data. This is the only thing that actually happens, right? Everything else is fluff. So if you can describe the data transformations in a system to me, I understand the system. If you can describe macros to me in a system, I don't understand the system. You've just described to me the fluff that happens in order to make you happy with how this looks. And this is, I guess, where I broadly disagree with what I believe to be a general belief about software development. I don't know that, maybe I'm inventing a ghost here that doesn't exist. No one thinks this, maybe. I don't know.
So I think the counter argument would be that it sounds to me like what you're saying is, well, if we just have the data transformation, which is a big chunk of assembly code, that's better. If you see what I mean. And then the counter argument would be that no, actually, if you are able to express the transformation in a higher level, for example, to pick a simple example, by doing maps or filters or whatever, rather than opcode, then it's easier to understand what at least is meant. And then it's a question of, is this high-level explanation actually doing what it should do, or is there a bug in the macro?
Right. No, I think there's a spectrum, right? In reality, everything is a spectrum. Everything is just we all fall on some spectrum somewhere, right? Where obviously you have assembly, and some people genuinely prefer this. Basically, they just want to talk about the transformations, the types and stuff. They want to know about register sizes and stuff like this. They represent the data however they want to, right? And that's fine. I honestly, I don't even have a problem with this hypothetical person doing that, because if they can, absolutely, go with it, right? But I think, higher level languages, or high level languages, let's say, right? And this is a territory, by the way, which I think we need new words for a lot of these things. To be honest, I'm going to say that, because high level languages is everything we use nowadays. Basically, we basically don't necessarily write low level code anymore. It's to the point where low level code now means C or Zig, but I like to call that lower, because it's not low level. It doesn't fundamentally concern itself with, for example, the registers. It is agnostic to which processor you're running on, mostly. And so from that perspective, I think, honestly, we need new words to talk about some of these things, because I like to say lower level, which means, it's lower level than Haskell. But yeah, so I think everything is on a spectrum. If you can describe first of all, I will understand the meaning of what we're doing if I can see the transformations. And let's say you express that in folds, you express it in maps, and so on. I think that's good. I've now understood the meaning. Let's say you express that in a bunch of different classes with different files doing different things and so on, and it's all going from one point to another, to another, to another, to another. Or let's say you express it in a call stack that is like, we're 60 functions deep and I still haven't found the part that actually does something. That's worse. Everything is a spectrum at the end of the day. It's about clarity, right? Clarity of what is actually going to happen. And I'm not saying, step one, modify bit one. Not necessarily. We can speak a little bit more, in a high level language about this. Absolutely. But that is the fundamental part of programming at the end of the day. It's basically what I'm saying. The only fundamental part is data transformation, right? Which is why everything that sort of talks about other stuff, I believe, is not to the service of actual software development. It's in the service of stroking people's egos, mostly, to be honest. So you have, solid principles and stuff like this. Most of those occlude what's going to happen more than anything, right? So, I should be able to substitute the derived class with the base class, for example, or whatever, like stuff like this. The fact that we have different things here, inheriting or whatever, occludes what's going to happen. I have to look somewhere special to see what's going to happen to this data and so on, right? That object has special fields now and so on and stuff like this, right? Fundamentally, not good for understanding what's going to happen, generally speaking. And yes, semantically, it might make sense. But in terms of actual, like if I was looking at this in a debugger, right, what am I going to see, right? I'm going to see a bunch of vtables. So that's, for those who might not know, it's basically a table of pointers to functions, because when we usually in inheritance, what we're going to get is basically one version of this thing is going to have one implementation of a function, for example, right? And we have to have a pointer to that specific version of that function, and so on and so forth, right? We're going to find that the memory of this thing is going to be filled with vtables, and the memory layout is not 100% clear. We can't actually look at these and compare them between different types of objects and so on. We certainly have nothing like, a simple tagged structure, for example, when we have these types of systems and so on. So looking at the memory and seeing how it changes in that model is fundamentally not that, interesting. It doesn't help me very much. And so these kinds of structures usually obstruct what I'm trying to do when I'm trying to find out what's happening in the system. Right?
But that's if you end up spending time in the debugger, and then the counter argument would be, well, let's write code in a way that we minimize the time we need to spend in the debugger, or remove it completely.
I don't believe in that though. I mean, and this might be a spicy take. I don't know. Debuggers are great tools to have. I've never understood the argument between like printf debugging and debuggers. To me, why not both? Because I want them both. I want to log stuff. I want the debugger.
I can tell you, it's a very easy argument. I'm a printf debugger kind of person, and I do like a few different programming languages. So the reason is I try to minimize debugging.
Okay, but what does that mean? Actually, hang on. Now, let's go back. Minimize debugging. What does that mean?
All right, fair enough. So first, it would mean try to write things simple. So either there are no errors or errors are very obvious.
Sure. Okay.
The second thing would be work in, let's say, small steps where you move from a state that works to another state that works. Let's say I'm making a change to a program. I would try to change and run the program as often as possible, like every 15 seconds, for example, every 1 minute, every however many minutes.
Sure.
I would say write like a bunch of tests. So if I'm trying to change something deep in the system, I don't need to test it in an annoying way where I open a page, then click here, then click there, then do a third thing, and then see whether it's what I want. I could just exercise the code with a small program.
Yeah.
And in between those things, you're left with just let's say, a much smaller amount of times where there's a discrepancy between what you think the program does and what the program ends up doing.
Yeah.
Whereas you go in debugging mode. Now, a lot of those situations you can solve fairly quickly, or at least I could solve fairly quickly with printf or console or whatever. And then when it gets really, really complicated, that happens fairly seldomly for me. And the last time it happened was ages ago, so I've already forgotten how to use the debugger for this particular language.
Right. Yeah.
So that will be the argument against debuggers.
Okay. I will say we are mostly the same. First of all, by your definition, I try to minimize using the debugger, right? By the definitions you laid out, right? So I write code in certain ways that I believe make it easy to see what's going on, and I can actually spot the bug even before I've found it from behavior, right? I can spot it from just looking at the code. I have a suspicion that means wildly different things for us, however. But let's leave that on the table, I guess, a little bit for now.
Oh, let's explore.
I do want to explore that because, But yes, I go through the same priority list. of doing things, generally speaking, I would say. And I write tests for lots of things. When I just want to see that, hey, this is behaving as I expect, I write tests for that. I don't do TDD or whatever because the tests don't come first. I just don't believe in that being useful necessarily. So it's not really, unless I'm doing some kind of API design, but whatever. My last step is using the debugger, but this is mostly like, that's the kind of the most annoying step in some ways, right? You have to go into a program to now look at your program. Yeah, it's fundamentally much more annoying than putting printf in places, right? So I do go through the same steps. So I think we probably are the same there.
Or taking a step back, like removing all the changes you just did and trying to do them again.
Yeah. But yeah, so I think we're broadly speaking there, we're the same. But I'll say I don't trust that process, everything you said, which I also do. I don't trust that process to necessarily just produce correct stuff. And the reason I don't is because, I've just looked at the objective reality that I live in, where bugs happen, no matter what I do, to be honest, right? It's just a fundamental part of the actual software process is, we will have bugs. I've never been anywhere, used anything that made a remarkable difference, to be completely clear. But I will say this, finding the bugs and solving them has been easier with what I'm doing now. And that is, let's say, radical simplicity, right? Using simpler languages that are easy to learn. There's an end to learning them. They really don't have they don't have advanced patterns. Let's call them that. Some things you might miss even going to these languages. And they also have, in some ways, requirements that you might not want to take on, like manual memory management. I believe this is a simplification. And that might sound super counterintuitive, but I do think it is a fundamental simplification in software development, actually.
One way to understand what you're saying there is that you're making an argument for Go. Are you making an argument for Go?
Not really. I don't believe Go has the kind of manual memory management that I'm referring to. But Go is a great example of a language that is, it is not a difficult endeavor to learn. You will definitely be productive after a matter of... I don't want to, because if someone hears this and they hear me say like, hey, after 3 days, you'll be productive, and then they're not, they feel like something is wrong with them. And that's not really what I want to, accomplish here, right? I know full well that I live in a bubble, of my own world. Yes, picking up Go is not a difficult endeavor, right? It takes a few days. But that's me, and that's someone who has programmed since 2001. They have already done C++, they've done C in C++, and all of these things, right? But I will say a very short time relative to other languages, like, Haskell, for example, or Rust, perhaps. Go will basically take you to a productive place very easily, like very fast. And at the end of a very short journey, I think you're even ready to just read the standard library, for example, in Go, right? You gain an understanding fairly quickly in a language like this, where you are now able to consume also, and not necessarily in the package kind of way, because everyone can do that. It's not hard to install a package, but you are able to actually participate, actively in just an understanding of what is code doing the way people are doing it, right? This is in some ways the anti-Haskell, right? Because remember, I talked about spending days in total researching error handling in Haskell. That's not because these solutions were simple. They're not. People do presentations about them because they're not obvious. Whereas if you take a language like Go, most things will be mostly obvious, and so on.
All right, so I think we are moving around here against simplicity versus complexity, but I'm not sure you and I are arriving at it at the same place, or at least approaching it from the same angle. So I want to explore this a bit further. And let's pick Go and Rust as two examples. Now, Go happens to be fairly minimalistic and have not so much syntax, while Rust tends to go a bit in the other way. And it doesn't get like as crazy as Haskell, but it definitely has a very sound type system. It definitely can throw in a lot of complexity to you, and so on. So you have like this approach where in one case you have a fair bit of simplicity in Go, and in the other you have a fair amount of, let's call it advanced stuff in Rust. Now, how do you think about this? Which one do you like better and why? Because I would to just like preempt my position, I would definitely say I find Rust much easier to write in. even if it's the more complicated language.
Okay, so there are a few key things in this conversation that sort of you have to kind of pre-establish. And also, even if you pre-establish them, we all have very different concepts of what is happening in this conversation, right? Because you said Rust is easier to write in. I believe that to be 100% the case for you. And I think ease is personal. Like ease of use is personal. I am unable to speak Chinese, unfortunately, because I never learned Chinese, right? So it's very hard for me to speak in Chinese. Likewise, you have an easy time writing Rust because you learned Rust, right? And simplicity is tricky, right? Because at the core of it, you are saying something is, if you were saying something is intrinsically simple, we have to establish there's some natural characteristic of this thing that is somehow simpler, right? Somehow better. And that can be difficult to even agree. What does that mean, right? So I'll pick one example here that actually is outside of these two languages of a thing that I think is simpler counterintuitively. And this is kind of what I talked about before. Manual memory management. I believe this is intrinsically simpler because it divorces the concept of doing things, right? Just doing things and allocations happen from memory allocation. You do memory allocations separately and then you do things. We have taken two things apart that do not need to be part of each other. They're simpler now. One is orthogonal from the other, right?
But that only works if the thing you're trying to do can know in advance how much memory it needs to allocate. So let's
not necessarily. The steps will still be separate, generally speaking. I mean separate in the sense that when we do something, for example, it will take an allocator, for example. Now, the steps fundamentally are going to be separated. So one step will allocate in the actual code even and say, make this many bytes, for example, for this thing, or make 5 integers, for example, right? Or something like this, right? And yes, it is at its simplest when we know beforehand, absolutely, how much memory we're going to need, right? And there are strategies, for example, like saying, no, we always allocate a gig for textures, whatever, right? And then we just say, get more RAM, losers, or whatever it might be, right? Or Firefox says basically, we have 64 gigs RAM now. I'm going to take half of that. Everyone else, you do whatever you need to do, whatever it might be, right? So yeah, it does come with, you are now making considerations that you weren't before, but I think the concept is simpler. And that's kind of the kind of simplicity that I, in some ways, want, where things are not connected when they don't need to be. And of course, like imperative or procedural programming comes with its own kind of complexities, absolutely, right? You tend to, for example, mutate things, and this can be difficult, let's say. I don't know if it's intrinsically more complex, but certainly it's difficult sometimes, absolutely. I'm 100% on that train. I can't explain exactly why that is, but, here the rationale is, since memory allocation with custom allocators like Zig or Odin, Odin is what I use primarily. In this kind of system, right, in this kind of setup, your allocation happens separately from doing things. Doing things is just computation. Allocation is asking an allocator for memory. That allocator might live in only our program. It might live in the operating system. It might be an allocator in our program that when it runs out of memory, it asks the operating system. That's a separate complexity, right? Doing things has nothing to do with that. But in many languages, pick any high-level languages, right? Haskell. Doing things implies allocation. And of course, that allocation is managed for you, but there are lots of things there where we want control. And I would say, I will pay that price up front of having to think about these things because I believe that to be important. In order to get a better general product, I think manual memory management and custom allocators are something you want to provide that better product. So you can think you can set up strategies that make sense for your program for memory allocation and so on. So for example, one example of this would be, let's say I'm writing a web server in Haskell. I would probably just say, okay, when we handle a request, we're just doing stuff and some of it allocates memory. Not super concerned. The end result of this is going to be, we have short-lived objects inside of the request, right? We calculate new things. We have new objects. They are now present somehow in the memory, right? Some of those are going to be heap allocated, meaning they're coming from the OS. They have to be given back to the OS and all of that noise, right? That is managed by the garbage collector. In theory, the garbage collector does such a great job that it knows everything that is temporary to a degree where it allocates it on the stack or it does all kinds of magic. In reality, that's probably not going to happen. higher level languages do not do better in benchmarks, generally speaking, than lower level languages. We can see this. This is not a hard truth to see. And so in that scenario, right, I'm just sort of doing stuff and that implies allocation. It's handled for me. However, if I have control over allocators and memory management, it's manual, I can say, here is a temporary allocator that is set up on the stack. That's the only place memory can come from. I know this because there's no way it can come from somewhere else. This is now an established fact in our program. We can observe that fact. We can see from the structure of the program, this is what's going to happen. Each request is now going to allocate from this temporary area. And we basically say, blow this entire area away when we're done. It's on the stack, so it's going to happen automatically. Even if we allocate it on a heap, we could destroy the entire arena after a request was done. And of course, now the astute will ask, well, what happens if I have long-lived objects inside of this request that need to be saved somewhere? We can have multiple allocators. We can have a long-lived allocator, short-lived allocator. Now we have control over this in our program. We have now separated two other things from each other. Because remember, in every other language, for example, we don't have custom allocators even. We can't even talk about, is this a long-lived allocation? It is a short-lived allocation. In languages with memory management and custom allocators, we can say, this is short-lived, this is long-lived. I can be wrong or right. I can design. I can actually say this in code that this is the case.
Fair enough. But then again, the counter argument would be, well, this is a level of complexity that's not really necessary for a lot of programs. Let's say you're doing a fairly simple front-end interface in the browser. You're doing a to-do app that talks to a REST API.
Sure.
Both the REST API for the to-do items is going to end up talking to a database and return JSON. And let's say we're not going to have users with really huge to-do lists, or even if we do, it's fine. We can just paginate stuff and we're going to be okay. And then the argument would be, why deal with like all of this and just not write in Java or PHP or JavaScript or, any language that doesn't go into manual memory management? Because sure, it may be less optimal, but it's going to be good enough anyway.
Sure. I understand the allure of good enough, right? I think for many, many things, I hesitate to actually say this because I don't actually agree, but I'll say it just to kind of defend in some ways this kind of thing. Mostly we're waiting for the database. Whatever, right? This is a well-established kind of phrase at this point. I don't have enough insight into what people are doing to prove that right or wrong, but I will say this. We can wait for the database and then we can do everything very fast. Because in some ways, that whole argument falls apart when you consider like, well, yeah, but we could shave half a second or, 150 milliseconds or whatever it might be from everything else you're doing. Like this is every API call that we're doing, for example. And I would argue there's no real difficulty in making simple programs with custom allocators, for example, right? So consider this. Mostly, if we have just our normal application, let's say Java, whatever it might be, right? Most programs will just be like, oh, yeah, I'm doing stuff new here, new that, new this, whatever, right? Or even let's just go beyond that and say Elixir, right? We have stuff. That stuff is managed by the VM. We don't say new. There's no new. We have objects. Sometimes they're created, in code. Some of that lives in a heap somewhere, for example, right? It doesn't matter. It's completely transparent to the user, right, of the language. And those kinds of systems are in many ways trivial I would say in some context, at least, in most, they're trivial to effectively emulate, right? Because most of those systems, or for example, batch programs and so on, they can do with effectively one arena. You allocate from that arena. Maybe you have a max size of the arena because you're concerned that, hey, maybe we reach a max, right? This is obviously very common with tuning parameters for GCs and stuff like this, like max heap size and everything, right? We can have that with custom allocators very easily. We create one allocator at the beginning of the program. It has a max size or it doesn't. We start with a certain reserved size maybe because we want to just say like, hey, yeah, I think we're going to use at least 10 megs, whatever. And then we kind of just move on. In Odin, for example, this would actually just take one line because you would say, in your main function, you would say context.allocator equals this allocator. Every function below that in the call stack will just use that allocator, and we're done. I do think that that's, if you are concerned with allocators, generally speaking, take it as an argument to a function, but make the context allocator the default argument. This is what we do in Odin. This means we have the capability to override an allocator. So we can use testing allocators. We can use allocators that are just on the stack, for example, right? And so on. The point being, we can, in different contexts, we can do different things with the allocators, right? So in tests, I use a testing allocator that says, if you forgot to freeze something, the test is going to fail, for example, if I want to, right? And so on. So I don't think that the sort of argument necessarily holds up where, most people are doing the simple stuff. I do simple stuff in Odin all the time, right? That sort of just takes a simple shape usually of this, we have just an allocator. I set this up. Maybe I set a max size or whatever it might be, right? Or maybe I just say, nope, everything is stack allocated. This entire program should not take more than the 2 megs I've said exist here, for example, right? And I think that's usually a very simple endeavor, and it actually gives you a lot of certainty,
Yeah, fair enough. I kind of want to move away from memory management, circle back to like Go versus Rust, and which is better. Not because there is a thing, but like a language X is better than language Y. Well, there is for some languages, but let's not get into that. I just want to get your take on simplicity and ease around particularly those two, because I think they're a good example of two of the extremes, actually. Or rather, two of the non-academic extremes. Rust being very powerful but still pragmatic, and Go being very limited but also still pragmatic.
Yeah, obviously they approach, let's say, pragmatic from different angles.
Yeah.
Right. Obviously, Rust is super concerned with having things that people want. I mean, they've been trying to add custom allocators, for example, for quite some time. I don't think they're really there, unfortunately. It's very tedious and just annoyingly hard to use, to be honest. But yeah, so they approach this from a different, and this is kind of where this hypothetical language of, we need a complex language to say simple things, right? This is kind of, Rust is this for me, the archetype of that type of language, right? I have often been in a position, I'm going to say this, ease is irrelevant, I would say. It's irrelevant at least in the long term. In the short term, ease is definitely something you want and something you need. Otherwise, people are not going to use your stuff. Ease is important in that respect, right? But ease in the long term, I don't think is such a great argument as people think it is, right? The ease with which you can see that a for loop works a certain way or whatever, this is kind of surface stuff where absolutely the first time you see this, if you've seen programming before, you might actually understand what's going on. This is more than you can say for example, let's say the iterator approaches to stuff in Rust, for example. You have to learn that. And I don't think that's a great argument against anything, to be honest, necessarily. There are certain things, it does go, there is a threshold we can cross where it becomes too much. When there are too many things you have to learn in order to understand a code base, for example, right? Where, hang on, now I have to understand proc macros. I have to understand this iterator style of doing things. I have to understand what that actually means. So there has to be an explanation, for example, by the way, this is as fast as just a normal for loop. You don't worry about that, right? There's nothing super crazy about this actual behavior, for example, and so on. And I think Rust, unfortunately, is rapidly approaching a place where it crosses the threshold, I think, and sorry to anyone who might feel offended by this, but I think in 15 years, Rust is going to be the new C++. And not necessarily in the ways that are like, oh, wow, let's celebrate. But we will wonder, why did we ever think that this was going to be better or simpler or whatever? Unfortunately, this is kind of what I feel about Rust, that in many ways, I think they're busy in some ways, like adding things to account to mitigate other things in the language, right? There are things that exist in Rust only because Rust does too much magic in some other area, for example, right? So a good example of this, I think at least, that I think is just extra complication, is Rust feels free to move memory, right? This is just move semantics from C++, right? But basically it feels free to move memory as it sees fit. And in order to mitigate the problems that come from this sometimes. You have to have, for example, the pin trait that says this memory cannot be moved, and so on. And over time, in kitchen sink languages, you accumulate these kinds of constructs. I believe C++ is what it is specifically because of this kind of kitchen sink attitude of we added this and it turns out that actually produces this issue. We have added now in version 55, we have added this thing that mitigates that, or the worst version of that, which is especially common in C++, and I call this the page 5 problem, is go to page 5 to see how this shit completely fails when you use it the wrong way. Right? This is common in C++ where you have the rule of 5 where you have to, if you define a constructor like this, you actually have to define 3 other methods, for example, right? Or something like this, right? Page 5 problems, where Scott Myers now releases a book to tell you all the ways that this is broken, basically. It's not dressed up that way. It's called just effective modern C++, but it's filled with page 5s, right? Where we just have to, hang on, okay, so if I use lambdas this way, they absolutely fail under this condition, and there's nothing to tell me about this, right? Rust, thankfully, has mitigated a lot of those. But I think Rust and async is, in some ways, kind of a little bit like this, right? Yeah. Where you would like someone to warn you beforehand, by the way, don't do these things because you're going to feel pain. Like it's going to be painful and bad. Most of that is actually in the type system in Rust. So it's more acceptable, right? It's you don't end up with something that's just sort of failing wildly in actual production, but it's still the same feeling in some ways, right? Where, yeah.
But the question is, would you still take that over the simplicity of Go, let's say? Because sure, Go is simple, but it's also verbose. And which one do you choose?
I would definitely take Go every day. And that's an unfortunate thing because Rust is made for me. Consider this shirt, which for the listeners is a Haskell shirt, and all of these things, right? Consider everything I said about static, strong typing, all of these things, right? I still would take Golang every day over Rust for most problems. Now, that said, would I take Golang in the grand scheme of all languages? No, not necessarily. I would take Odin for most projects, and I would be prepared to write more code. Because I don't think writing the code is the difficult part, really. Establishing what transformations need to happen and all of these things, establishing a mental model of the problem, all of these are the difficult part, right? And so that goes back to what I talked about before. I think people are focusing on the wrong things. So, macros or, even the safety features of Rust, even those, I'm not entirely sure that they would help that much for my process, right? And I have tried Rust. Actually, it's the same story like with Haskell 3 times and blah, 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 all of that stuff, right? I would say I didn't get into Rust because I do feel like it's painful to use, but that's a different, that has actually, it's not necessarily only the language, it's also slow compilation times, even like I had a project with 1K lines and somehow it takes 2 seconds to compile. I'm just sitting there wondering like, how did we end up here though? I added 30 and suddenly I'm just feeling this immense amount of pain every time I save, this is not how it's supposed to be, right?
Yeah, fair enough. Now, my take actually would be the reverse, but then again, I like dynamic languages. I'd rather take a more expressive language. So right. At least the majority of the stuff could be, you can call it terse, but I would think about it as kind of more semantically exact. Now, my favorite, like the simple example of where Go like really falls short for me is that there are some basic things that you essentially need to write a for loop for because you cannot really do them in the language nicely. Let's say reverse an array. I think they've started to fix that in Go, but like historically, you don't have a array.reverse in Go. You need to write a for loop. It's a fairly easy for loop to write, but it still takes a while to understand this for loop is doing a reverse while you're reading it. While if you could just have array reverse, that's like much easier, and then I continue reading the code.
Yeah, I mean, I believe this is just library functionality, though, right? I have a hard time seeing how they couldn't just package that up reasonably, right? And of course, they do have generics now. Maybe that's what you're referring to.
The answer was lack of generics.
Yeah. I mean, the infamous solution to this is empty interfaces, right? Now, bear in mind, I'm not a Golang person necessarily. I would say I'm a fan of Golang in the sense that I probably have more in common with their design principles, let's say, behind that, right? And I don't, for example, I mean, the simplest way to say this is I don't mind writing code, right? I don't mind writing more code and having more code be on the screen when I'm done solving a problem. What I do mind is if that code is obtuse, it is opaque or otherwise, there's too much in it. I would definitely say the density of the code is an issue for me in many ways, right? And that applies to different kind of contexts, right? So the density of a macro is actually two different phases of compilation even, right? Very dense, because now you're packing in two phases of compilation, right? You're basically saying, hey, before all the other compilation, we're going to do this other thing that will expand to something and so on. Lots of density, right? Usually macros will have very high density. That's the general problem I'm trying to avoid, I would say. This means that these kinds of constructs that probably would, let's say, abstract too much, or let's say they favor abstraction, right? And in some ways, that's what you were saying, with semantic clarity, saying only the things that matter. Am I correct in saying that's what you meant? Yeah. Saying only the things that matter comes with an unfortunate side effect that in some ways we don't know that the other stuff matters. And I think it matters. Like, how we do stuff matters and so on. And that I think is an unfortunate reality for the most part. Not everyone agrees, of course. But I look at software nowadays and I have to conclude that most of this, saying only what matters is to blame. I think software sucks in general. It's just awful. It's awful to use programs, generally speaking. Like almost every program that I use has some odd bug or otherwise like a quality to it that I don't appreciate. Like I talked about Firefox just completely destroying memory, eating it, whatever. Of course, it's not necessarily leaking. I don't think that. They have plenty of leaks, actually. But software, I think, is of incredibly low quality nowadays. Maybe it always was, and I was just too naive to see this. But I mean, looking back, if I run Winamp nowadays, for example, right, it's going to be snappy and good, generally speaking, right? If I run a music player that's written nowadays, honestly, most of them will have they will have startup times that are seconds long for some reason. Like, how does this happen? You're a music player. I know the stuff you're doing. None of it takes this long. I've written actual software that does some of these things, and I can tell you, none of what you're doing takes this long. You have designed your software poorly, probably. I don't know that it's even a performance issue in many cases. It's someone literally waiting for some async call in their startup. Maybe. Who knows? But software is terrible. I do believe a lot of it comes down to, people are not concerned with how stuff happens necessarily, right? And I'm not saying, of course, I'm not trying to accuse anyone of anything, but as an industry, I think we're failing. Like, we're kind of doing this wrong, to be honest. And I'm not saying in the money aspect, like in the actual industry aspect of this business, because for all I know, tons of people are doing good economical things, right, in the industry. But as an end user, I'm not seeing any of this. All the software I use seems to be absolutely terrible, to be honest, right? All of it. I mean, that's a broad statement, but
even
you get my point.
Free and open source software that you're using?
Oh, yeah, absolutely. Open source software does almost nothing for quality in terms of these things, because you have to consider most of the people are coming from exactly these, the angles that have created this problem in general, right? I would say proprietary software has, in some ways, especially proprietary software that you pay for, like some minimum amount, has a much higher bar to clear because there's a monetary incentive as well. Like, people will not buy my software if it's just awful garbage. But open source has done not that much, I would say. And if you look at, maybe this is quite an uninformed take. I will just preface this by, with this disclaimer, but isn't the relative quality of Linux in some ways because people actually put money into it, nowadays? I don't believe that it's the actual open source factor that has done anything for this, right? We have more stuff in Linux than FreeBSD because people have put more money into it. We have more drivers. The drivers maybe work a little bit better because people put money into it, right? It's not because it's open source. FreeBSD is open source, but it's, and of course some of it comes from users. Yeah, you have a user pressure, you get, stuff done maybe. But I think open source is wildly overrated in many ways as a concept. And unfortunately, I think it doesn't work for a lot of people, right? And we see this all the time. We see a blog post of someone saying, like, I'm tired, I'm burnt out, I don't want to do any of this anymore. Everyone is an asshole. Everyone expects stuff from me, even though no one is paying. This massive company is using my stuff, and I'm not getting paid a single fucking cent for this. Are you kidding me? And I have to, consider these my customers or whatever? There are no customers. I'm just alone in a void trying to not burn out, and I'm done. And we see this all over the place. Like Rich Hickey has had these, I want to call them meltdowns because no one else seems to, but they're basically complete, like, he gets tired of just being criticized for having a language that people dare to use. And he's just tired of hearing people say, like, oh, Clojure has to do this, Clojure has to do that. The reality is, of course, Clojure doesn't have to do anything. And that's Rich's position. But it comes out in a meltdown, in a gist on GitHub that says, you are not entitled to anything. And that's the truth. But it's also, Rich, just sit back, tell this to yourself, right? Because, this is the world we live in. Open source is just, this happens to be the only viable model for a language. Basically, we have established this. No one can actually charge for a language unless it's for statisticians, basically, right?
Which is the language you charge for, which you charge statisticians for?
I don't know. There's a language for economists and stuff. I don't remember what it's called. Because I've never looked into it. How could I? I have no real reason. But there is.
It shouldn't be R.
No. R is completely. I think
R is free.
Yeah, and it's not MATLAB and blah blah blah. But there is a language. I don't remember what it's called. Actually, I learned about this language from a talk called "The Economics of Programming Languages," which sounds like the driest talk known to man, but it's actually very good. The Economics of Programming Languages. So it's made by the guy that created Elm, which is a front-end language. So I'll paste this in the Discord here. And so I learned about this language from this talk. Anyway, but this is the model we have, right? It's just completely, okay, people are getting your stuff. They feel entitled because they have an emotional attachment to the thing. They want it to succeed. They want to be part of the group, like we're the cool group, we're using Clojure, and so on, right? But of course, it doesn't come across as that to Rich Hickey. Instead, it basically sounds like, hey, Rich Hickey, why aren't you servicing me, your consumer, and so on? Because fundamentally, the model is just, it's oppressive to everyone involved in some ways, this thing, unless you detach, which is mostly what I do. Like with projects, with the stuff I use, if I use any kind of open source thing, I detach from it completely. I don't want an emotional attachment from it to it, right? I don't want to be bound to this thing either, generally speaking, right? And of course, with languages, this is difficult because you just use the thing. It's not like you can just say, oh yeah, I'm using that thing only in a special place, right? You can, right? You could say, oh yeah, I'm using Odin, the language, only in this specific place, right? But this is difficult because generally speaking, languages will be like, oh, I like this language, so I want to use it more and more everywhere and so on. Because again, we have this intimate kind of process happening, where we create stuff. And that process, in some ways, it binds you emotionally to what's happening, right? Oh, this feels good. Every bug that I fix in Odin seems to be much easier than everything else. Of course, I want to use Odin more and more. And then Odin doesn't do what I want it to do as a project, and I'm upset now. But you have to somewhat say, it is always possible for me to stay on the version of Odin that I have right now. That's my fallback is, let's say Odin somehow evolves into something else. It adds async, for example, which I think would be a massive mistake. And I think a mistake that Zig is currently making. I would just say, okay, so this is my version of Odin. Maybe I will work on it and I will just make it whatever I need it to be. But that's also in a very kind of special context, right? I'm prepared to write 99% of the code that I use because that's what I want to do anyway. Relying on other people's code in general is just a massive problem, to be honest. Other people's code, generally speaking, should be kept in a dark corner with a locked door, and we only speak to it via small, slits in the door. We give it food every once in a while and, keep it there. It's separate because, I don't know, maybe I'm just cynical, but everything fucking sucks. It's just so bad. And I will only depend on other people's code if I have to, I would say, would be the thing. And of course, this doesn't necessarily imply like for business projects or whatever. I mean, come on, I've done Node projects, for God's sake. Like there is a business side of this, and this is what I actually want kind of side of this as well.
So basically, we've been talking about different programming languages for a while now. Both you and I tend to enjoy, let's say, learning programming languages. So let's talk a bit about that. I know you have some opinions on learning and some sound advice to share on learning stuff. What are your thoughts?
Right. Sound, I don't know about, of course, right? It's just a bunch of opinions in reality. But yeah, so learning languages specifically, right, is one of those things where I think it is important to see a bunch of different views on something, not necessarily for practical purposes. There are certainly ones that are more practical than others, let's say. I think a lot of the mistake that some people make, it's very common to learn the same language 3 times. I found where we might know one language and then we sort of say, oh, well, that language seems popular. I'm going to learn that language as well. But there's nothing that fundamentally kind of separates these languages. And I might be upsetting people when I say this, but if your 3 languages are JavaScript, Ruby, and Python, I think you've learned mostly the same language 3 times. And of course, it doesn't seem like that to someone who is deeply invested in Ruby and absolutely hates Python. But trust me, there's a whole other world out there that you're not seeing right now, right? But yeah, I think it is important to see a bunch of different sides of the thing, right? And honesty in learning also in this process of learning languages, I think is important, where reevaluating something honestly for yourself is important, where am I just trying to use Ruby now in Haskell? That's, it's an honest mistake, but it's a mistake that we have to kind of self-correct, because we can't conclude that because I can't use Haskell as Ruby, Haskell is not bad. Right? Haskell would be bad for other reasons, generally speaking, I would say, right? If you were to come to the conclusion, I would hope that you would have better reasons than, well, I can't use it like Ruby, right? Unfortunately, a lot of people do seem to basically use a language like another and then say, well, this is not good. This is not at all what I want, right? And that's a very human thing to do, right? We come into stuff with the wrong expectations, for example. But I think we can solve that to some degree by focusing on the thing I said in the beginning, see different angles of stuff, right? So if you know, for example, hey, I know, let's say someone knows JavaScript, for example. Let's say they know Ruby. This is sufficiently different, right? When they go to Haskell, I would hope that they have a concept of, well, Haskell is, let's say it's weird, right? So they're already in for they already know this is not going to be like everything else. They're going to have a lot of predispositions, to be honest, against the language probably, because they've heard, well, it's super complicated and everyone is a mathematician. And that can actually, in some ways, that can help you learn, where this is different. You're approaching it completely differently. You're not going to come in with your own predispositions that are like, hey, programming is, it's done this way and so on. And I think that can help a lot, because I think we all have some kind of experience where, we might work at a company, we hire a guy, we hire a person, comes into the team. We know, for example, that they might be a Java programmer or whatever, right? We see their Erlang code and we're like, wow, yeah, this is definitely a Java programmer, and this happens, a lot. And I think it's easy to avoid this if you consider like, hey, I'm going to pick a language from each kind of paradigm, let's say, right? Or something. Now you've already classified them differently. You've already said to yourself, this is now different. And of course, I'm not saying, hey, I'm going to learn all these at the same time. It's very not productive probably, right? But I think if you approach learning languages like this, where you're diving in instead of just saying, oh, I know the route. I know the route to learning all of this stuff, right? Because generally speaking, that's not going to be the case. Every language is broken in its own kind of special way. And it is coming to terms with some of those things, or even just sort of, oh, the sidewalks look different here. That kind of concept where things are not what they were back home, and that's fine. You have to acclimate to different things. Some of those things are sometimes strictly worse, right? But like for example, let's say you're using a language, it doesn't have a debugger. To me, that's a minus. It's very hard to not think that, to be honest. I think it doesn't matter what you put in this language, I do believe I want a debugger at some point, to be honest. So that would be just, the sidewalks are broken here, for example. And we can accept that. That's not the end of our journey. We're not going to just say, I'm going home, the sidewalks are broken here, or whatever, because that would be short-sighted, right? But yeah, going into it with this idea of exploring rather than just saying, no, I have the map. I've already mapped out this space, what I'm going to do, and so on, right? Because most of the learning is just, how do I accomplish these things? How do I actually do things in a way that makes sense in this particular space, instead of, no, I need specifically a pointer or whatever it might be, right? That might be the wrong thing to look for instead.
So for me, one interesting bit is that there are quite a lot of common bits between otherwise vastly different things. For example, at least when I was learning Haskell, it was very, the big thing was, what the hell is a monad? That's the really big question when learning Haskell. You need to get to a point where you understood what a monad is, and you understood the endofunctor in whatever, I forget.
It's a monoid in the category of endofunctors.
Exactly, yeah. The monoid in the category of endofunctors point. And Haskell makes it actually quite complicated because it just uses monads for a variety of things that don't necessarily need to be the case, but that's how they do it.
Yeah.
But then what I found eventually is that monads end up being quite common in other places as well. The promise in JavaScript is kind of a monad. The observable in Rx is exactly a monad.
Yeah.
Some other things are monadic, and jury is still out for me whether that's a useful concept or not, actually. But at least I'm okay, cool, this is a monad. I can kind of get some things about it, and I know not to try some things that are unaccomplishable because this is a monad. For example, here's an observable for Rx. How can I get the value in the observable? Well, I can't, but I can put stuff at the end that would happen once the value gets resolved or something.
I think, monads are obviously I'll be honest, if I'm teaching someone Haskell, I don't mention monads necessarily for some time. They actually use them before they hear the word monad, right? And I think that's an important thing to do. I have also tested this out in practice with people who did not understand monads. So I was working on a project, and we had a TypeScript code base. And one of my first things that I did, this is going to sound now to people there's this Haskell guy trying to bring Haskell or whatever. No, I was trying to bring the power of monads in a practical context, right? So I built a library. This was one of the first things we did, or I did in the project. I built a library for basically having option and result. And we called them this. At no point was there a mention of any monads, and we didn't have bind as an operator. Bind, of course, is producing a new optional result with the value inside of an optional result, right? So it's effectively choosing success or failure. It's a point where we can choose success or failure. So if we add an operation to a chain, we would now have an opportunity to fail that, right? So basically, what happened in this project was I introduced these things, and about a month later, I explained to the people who were working on this code base, you have been using monads this whole time. This is the pattern, right? The pattern that you've been using and the way you're thinking now is in monads. This was not somehow haha, I've fooled all of you into loving monads. That's not really the point. It's to establish the value of these that is completely separate from any kind of, we don't need to talk about math. We don't need to talk about a monoid in the category of endofunctors. We don't need to talk about burritos, in fact, or any other analogy, right? We show a practical context where here's an operation that can succeed or fail, and we don't have any information for it. That's an option, basically. Or here's a value that can exist or not exist. It's an option, right? Here we have something where we want to communicate some kind of error state or whatever that might be. This is a result. So we look at it from that perspective instead. And we basically toss aside the idea that, well, you have to look at it from a much higher level perspective. When you understand monads, you now have the theory of everything, or presumably a lot, right? I would argue it is an important kind of, the intuition that you build by using these things is more important than the actual definition of any of these things. So the idea, for example, that you've internalized is essentially, here's what I can do with an observable. That's the important part, right? And you've gained that because you've actually used the stuff over and over. You've probably tried to do the thing you couldn't do. And that failure, in some ways, like bumping into that corner of the space, has led you to the point of, oh, yeah, no, you can't do that. Maybe you even ask someone, hey, why can't I do this? And they say, well, this is how this operation works on these generalized kind of structures. And it's never about the actual math or anything of that sort, right? It's more about going through the actual pattern, right? Because it is a pattern. Monads are effectively, in some ways, a design pattern for functional code. That's a bad word. That's a dirty word, of course. But that's kind of what they are. And so internalizing that pattern and knowing the limits of it, I think, is the important part. And that's why I kind of prefer to... There's this theory in the Haskell ecosystem that you have to talk about monads and you have to not understand them for some time. And then suddenly you will get it. And now you can no longer explain them to anyone, or you are unable to. They will not get it, blah, blah, blah. And there's this theory that this is a key concept in learning monads. This is a thing that's actually been discussed. Maybe it is the failure to understand monads from burrito tutorials that makes you learn monads. I don't necessarily believe this to be the case. I believe essentially option and result and these kinds of constructs, if we just use them, we introduce the intuition, the rest will come. Right? We basically say, okay, the IO monad in Haskell, the failure case is an exception. That's it. Like, we don't need to say more about IO at that point because, the success case is a value. That is the result of running the IO action. That's all we need to, when we transition from maybe and either in Haskell, which is option and result, we then transition into essentially saying IO is effectively like those things, except the failure case is an exception.
Yeah, I think Haskell makes it particularly complicated because it mixes, let's say, the bit that's going to be useful in every other language, which is like whatever they call this operator. These days I call it flat map now.
Sure, that's bind, yeah.
Yeah, no, that's not... Is it bind?
Flat map would be bind, yeah.
The one on your t-shirt. That's bind.
No, this is just the Haskell logo. But
sure. But it's also... Fair enough, bind.
Sure, yeah.
It was a while. But they mix that with also like how you do I.O. because that's the other weird thing in Haskell, which is Haskell is actually lazy. So there's no notion of order in how things happen unless you introduce some into the program. And actually, let's do that with monads as well.
Yeah.
But let's move away from that. Another thing I've been reflecting on yesterday, actually, and now I wonder what you think about it, is that when you go and learn other languages, you start seeing some things that in your home language that can be improved. And it kind of makes something simpler. For example, let's say learning Rust prepares you for when you eventually will need to learn Swift and then do a bunch of things with Swift for iOS, because they're kind of similar in some sense. But they also make some things harder. I remember that back in my early years, I was doing C and all that imperative stuff. And ever since I learned Lisp and Ruby and like whatever else, and I started doing things with map and filter as opposed to with loops, ever since that happened, I've forgotten how to use loops. So now every time I see a program that does a more complicated imperative thing rather than the more simple functional thing, it actually takes me more time to understand it than it used to in the past when I was just used to for loops with short name variables. So I guess the question here is, what are the adverse effects of learning a lot of things?
I would say the most pronounced one for me, really, is the why can't we have this in where I am effect, right? The realization that the playing field is not level. If I go to, let's say I go to Golang. Golang famously is made by Google. It turns out Google has a lot of money. They have a lot of people working at Google. They attract a lot of people to work on Golang, lots of libraries and so on, right? They have a lot more opportunity to invest in things, right? For Golang, for example, right? One of the things that bothers me the most about knowing how things are done in different languages, what tools do they have, and all of these things is the realization that most likely my favorite language will have none of these things. For example, historically speaking, I'm not necessarily participated in massive communities, right? I have tried most languages at this point, Kotlin, Swift, all of these things, even though they professionally might not be relevant to me, I like languages, right? one of the worst kind of things that can happen is I will never have, the small talk code explorer as a part of my development process. Or even the jealousy of using Common Lisp and using Slime in Emacs, for example, right? This is incredibly hard to do in most ecosystems. Certainly, I'm not going to sit down and do that because I do want some time over to do other stuff. And that realization is particularly painful because it's not like you can't unlearn what you know. You can't unknow the existence of the Smalltalk code browser that Faro has, for example. And for those who might not know what that is, it's effectively is just a directory of all of your classes with all of their methods and so on. And you have essentially the entire development environment is in the program itself. You can modify it live. You can run it live. You can have Scratch buffers where you execute code from those. It is very much dynamic development and so on. It's probably not necessarily to my taste completely, but whatever, right? It's a upside of using that environment. Once you see this, you're like, wow, I would very much like to have this in Haskell, for example. And in Haskell, it would be actually simpler because we only have functions. I don't even need the classes part of this. We could have literally just a directory of functions. We don't even need to bother with modules at that point. We could do away with modules and say, oh no, functions exist in their own space. They don't need to refer to each other except by links between nodes, right? And so you end up with this puzzle in your head of like, this should be 100% doable, but I can't have that basically, unless I make it, which in many cases is going to be a huge undertaking. A lot of the things that you want they are hard to get. This is why your language doesn't have them already, for example, right? Or it might be, for example, I don't know how real this is. I'm basically inventing a hypothetical here. I imagine, for example, someone really loves Ruby, and then they explore Elixir a little bit, and they're like, hang on, so you're telling me you can have just hundreds of thousands of threads running at the same time, all managed for you, and you can think about each thread as a single-threaded program with a very simple loop that modifies some state in that program, effectively, and you send messages back and forth here. You can have that and just sort of have that all work for you. And it doesn't matter which functions you call, even though they're expensive, you won't actually lock up any of these cores on your machine. I imagine someone who really loves Ruby and sees that, it's even worse because there's some level of Ruby syntax going on in Elixir. So it's like tantalizing of like, hey, this is kind of Ruby-like, don't you think? And then going back to Ruby and saying, well, I have threads-ish, right? where it's like, I don't know. Why can't we have nice things where I am at my home, right? And that feeling, I think, is one of the worst of seeing all of these different things. Because we may have good reason to not engage with that other thing otherwise, right? We might not want to get into Elixir, for example, because we're making good money writing Ruby, for example, right? Or the job market for Elixir is just too thin, for example. All of these things. I think it's, in some ways, it becomes like a prison that you discovered for yourself, where you can't have nice things. You can't have the nicest things because it turns out one language does not have all of the nice things. And now you're just seeing more and more that you're like, oh, why can't I just have this thing though?
Yeah, I think that's fair. That's very reminiscent of the worse is better philosophy in some sense. At some point you get used to, you know what, we're not going to have nice things. Let's just deal with the stuff we've got and get good at it.
Yeah, absolutely. This is effectively like a mitigation tactic in some ways, psychological mitigation of this. Okay, so I can't have the nice things, but I can just sort of dig a trench here where I am and just work with that. And I think this goes back a little bit to the language design kind of thing we talked about before. We don't have complicated things in the language, so we do the simple thing, or let's say the verbose thing, over and over. And we get good at this, and we can package that up as best we can, but fundamentally we're just doing the same thing over and over. And this gives a lot of productivity in many cases, I think. There are people who only know C89 effectively. They've used C89 since, the 90s or whatever. They are incredibly productive. They're much more productive than I am in any language, certainly, right? They can build almost anything in C89. And they're working with that restricted tool set. And they're not concerned with the nice things on the other side of the hedge, right? They don't care what the neighbor has, right? They're concerned with, I just want to do stuff. And this is I guess you can go back to that once you are like, okay, my neighbors have way too many nice things. I'm just going to disconnect from that and say, no, I'm going to use the things that I have. And I guess this is in some ways the attitude I'm trying to employ and failing at probably, but
So what advice would you have for people who are wanting to learn multiple programming languages?
Well, right. So we're going into this. I would say it's difficult, right? Because I want to say to people, you're simply going to have to put in the time. It's a very unsatisfying answer to a lot of people because some people simply don't have time. Even though I might think that they have time, they know in their heart they just don't have that time for those things, right? But if you do have the time, I would say, again, make it worth it by learning different kind of things. I do think that it is mostly a waste of time to learn what could be considered the same kind of language over and over. It makes sense on a CV, but I think if someone sees Ruby on a CV, I don't think the jump to, for example, wanting them to write Python is that large. So having both Ruby and Python on that CV might not do so much anyway. But if you see Ruby and Haskell on the CV, maybe that is a little bit more like, well, there's a certain ability here to go, wide. I think that might be more worth it. But then I'm not the career advisor, so that one, take that with a pinch of salt. But I don't think that having Ruby and Python on the same CV is as valuable as people think.
But that's the CV angle. I would argue that actually you want to learn both Ruby and Python quite well. And here's my reasoning. Once you get over the language, you eventually go into the ecosystem. And both of them have two very different ecosystems that are in some way kind of unique. So Ruby has a very unique ecosystem around Rails. Unless you want to do some fancy live view-like stuff that I've not explored yet. Rails is simply the kind of like the simplest and yet most powerful server-side rendered HTML framework you can get your hands on if you're trying to go for, let's call it, simplicity and productivity. You can kind of get there with a bunch of other things, but nothing is going to be like as close as Rails for a while. If you go to Python, they have like this huge world of let's call it scientific computation, where you have like pretty nice notebooks and you have NumPy and you have pandas and you can like go on the whole tangent of neural nets, machine learning and so on, but you can also just stick with the statistical instruments there, and they are like a huge world unto themselves. And then you can see those two things into a very, very like well-shaped form. Now, some of those things would be available somewhere else, like Ruby would have an ND array library that's like kind of a toy version of NumPy and pandas. And Python would have Django, which now I would offend some people, but it's a toy version of Rails. But those are like two things you can get to only by learning the language and then getting into the technology itself. And then you cannot see the whole picture of that technology without like going through the language first, if you see what I mean.
Yeah. The ecosystem angle is interesting. I don't know that there's a very compelling alternative to that, right? To what you're saying. It's not like I have some, magical solution for like, oh no, Ruby, the scientific computation kind of stuff in Ruby, you just do this and that, and that's fine. The closest I could get is that all of this is just C anyway. So just use the FFI in Ruby and learn what FFI is. And now this problem is not necessarily as large as it might seem, depending on what you're trying to do. And of course, I don't for a second believe that pandas and NumPy and so on have, let's say, reasonable interfaces if you want to use the C stuff that is actually going on under the hood. I'm not naive enough to think that. So literally just the process of encoding all of those FFI assumptions might be super tedious in Ruby, for all I know. It might be a week prospect, effectively, like 1 week of work just encoding, like, here's this function, it returns this, it will do this. This C function is going to be called with this Ruby object, and so on, right? Might be super tedious. I don't know. But this is the closest thing I have, right? Where in some cases, some of these things can be mitigated by employing FFI, like foreign function interface of a language, right? And knowing what that means, what that entails, and understanding what the failure mode of that is, right? So, for example, higher level languages will have, generally speaking, you will have a harder time understanding who owns what memory when, for example, right? And generally speaking, they will all sort of take responsibility for any memory that you allocate, and you have to give it to the language, for example, in your FFI stuff and so on. This depends a little bit, and it comes with a lot of trade-offs, right? So the ecosystem thing, I think, is a compelling reason, but it's also situational, right? I don't know that everyone should be concerned with NumPy. I think it's being largely oversold, certainly, to people. And I think, I don't know, I think this might make learning a little bit more, I imagine it's very hard to come into programming nowadays. There are a lot of preconceptions, a lot of like things that people tell you, but they're only telling you this part. They're leaving out the 90% of the rest of that conversation because they know that you will be just overloaded by this massive mountain of stuff, right, that they should be concerned with. Like, for example, I just brought up FFI, right? And this is a concern in programming languages that is sort of tangential, generally speaking, right? Most people who use Python probably don't even come up upon this concern. They're just writing Python. And yeah, I think that the ecosystem thing is compelling, but also a little bit misleading, I would say. Because a lot of the people, and I think this is a general problem, a lot of the people that I see trying to come into programming and so on, they're not concerned with, oh, I want to do this thing. They want to learn programming, like period, right? And that is I think that's a difficult prospect nowadays. Very difficult. Because the field is muddled with frameworks. I mean, basically everything is frameworks in some ways nowadays, right? So, for example, someone wants to learn programming. They want to see stuff on the screen, right? This can only mean a few things in practice for a new person. It means some kind of web server or web service, web app, perhaps. One of these requires a server to actually communicate with and so on, right? We don't know exactly what this person can, amass yet. One of the suggestions will undoubtedly be, hey, you should learn React or whatever, right? I think that this is a exceedingly poor way to learn programming. Incredibly poor. It teaches almost none of the actual useful parts of programming. You will learn React, absolutely. I believe you will. You can probably in some ways put that on your CV and once you've made enough React projects. But if that's the only thing you've done, it is unlikely that you now know programming, right? Because programming in a much broader sense would be effectively trying to decompose a problem and solving that problem in code and so on. React does not even, I think, export in some ways the general facilities to do that in a sensible, non-React way, let's say. And this, you can see this by proxy by how many React libraries there are, right? Because React doesn't work like all other code. So we have to have a wrapper library for React to interact with this other library, for example, right? Graphs-React, whatever it might be. I don't know the graph, libraries, what is it, D5? Is that a...
D3.
D3-React. I'm 100% certain this exists. It has to exist because D3 wouldn't just work out of the box with React because React is not actually doing things as you would expect it to. And this makes React a very poor vehicle for learning programming. And while I think Ruby on Rails is a better vehicle for learning programming because there's much more, let's say, normal code running in there, you will write these controllers. The controllers will do things that have to do with business logic, and business logic is encoded in quote-unquote normal ways, and so on. While I do think it has a better chance of being a reasonable vehicle for learning programming and so on, I think it's still more difficult to wrap your head around than my experience, which I had. So back in 2001, I don't know that there was any framework for anything. The closest I had to a framework was BSD sockets. That's a framework, right, on the POSIX level in an operating system for talking about sending and receiving data and establishing connections between computers. Right? It's a framework, you could say. It happens to be, there's no inversion of control and so on necessarily, like we have, generally speaking, in frameworks otherwise and so on. You can consider it it's a library in some sense, right? But generally speaking, you still look at this and say, this is in some ways a opaque interface that I'm talking to. I'm talking to mystical things inside of the computer. They do stuff. I get information back. I send information out and so on, right? But this was the closest thing we had to a framework back then, I would argue. And of course, Java probably invented frameworks. The second day of existence, there was a framework for doing this or that, right? But Java also was completely irrelevant for quite some time. I don't know, people don't seem to remember this, but Java was a complete failure for the longest time, and only really succeeded because they put, like 1.2 billion into marketing, right? It ran slowly, badly. It produced bad results for a long time, right? So it wasn't relevant. But yeah, I think the frameworkization of learning is, I don't want to put the blame here on the learners, right? Because like I said, it is probably super hard to learn programming nowadays. The prospect of learning programming nowadays, I think, is much, much worse than back when I learned. And it's ironic because all of the resources are so readily available. We have YouTube tutorials. We can open a blog and just learn how to do something, right? Immediately. We can learn how to do something extremely advanced from just a blog post or two, and so on. So all of this is readily available, but it's really what are we transmitting to learners? That's the problem, I would argue. Or what are learners finding? Because I'm sure there are people out there who are trying to teach programming, right? Absolutely there are. I mean, I'm trying, but I don't know that that's what's being found, right? Because people are concerned with their careers. They're concerned with their CVs. They hear from someone who is in the industry that, oh, you should learn React, or you should learn React and JavaScript. But what they're hearing is, oh, React, right? Because JavaScript is that language you use when you write React, right? So all they've heard is, okay, I need to learn React, and so on. And it's not their fault, right? At the end of the day, they don't know how to do programming. They know how to make a React application, barely. Yeah. So I think it's super hard.
And the web has become quite complicated, actually. I've been refreshing my knowledge of CSS recently. And boy, it used to be much simpler than it is today. We have a lot of cool tools that, I eventually could understand and then use and then make stuff with them. But it would have been much harder. I guess I'm saying I don't envy people who need to learn how to do that stuff today.
Well, yeah. And I would argue, it doesn't get better when you have YouTube channels who are talking about their stack and so on, right? And these YouTube channels are never emphasizing, okay, so there's all the basics of just learning programming, how stuff works and so on. And then having they're selling effectively a package, right? And that package comes with everything. It is entirely impossible to understand everything, for example, in the YouTuber Theo's stack, right? It's not possible to understand everything in that stack when you're coming at this from a learning perspective. Even for someone who is, they might have been in this for some time. When they see his stack, they're not going to be like, okay, I guess my next 2 months are just dead because I'm going to be looking into literally all of this stuff. That's not what's going to happen, right? They're going to be adopting the stack and they're just sort of taking everyone's word for it. This makes sense, surely. And then there's a video 6 months later where the stack is not different. This is not a fair situation at all. Unless you subscribe to this YouTuber, you simply will not have any idea of what is happening, right? And maybe that's better, actually. Maybe you should have learned the first stack he used and then said, that's it. Maybe. I don't know. Maybe it is better to not be subscribed. And I say this not just to a YouTuber, maybe unsubscribe from, let's say, the proverbial feed. If I had to give some general advice to learners that will pay off in a longer term context, it would be stop trying to learn frameworks. Learn instead the actual fundamentals of stuff. Build a web server in the next language you use. I think that's a reasonable lesson. It will touch on many different things. It will show you exactly what this language can do for you in terms of, expressivity and all kinds of stuff, right? You will also learn how to build web servers.
Can I ask, sorry for interrupting, but yeah, it's kind of important for me. A lot of people call our podcast hosted by two old school developers. In a way, because Stefan and the guests usually do exactly what you talk. They don't talk that much for frameworks. They tell people to learn fundamental stuff. But there is this movement that everything should be way easier to understand, way easier to develop after that everything will be only modern frameworks, etc. And right now you're talking the opposite. So can you elaborate a little bit more on that, on the benefits about learning fundamentals, the old school stuff? Why should I learn PHP, not Symfony?
Right. I can't speak specifically, of course, to PHP, but I'll recontextualize it a little bit, right? So one of the most common, let's say, failure modes in someone's learning of Elixir that I see is that they don't learn Elixir, they learn Phoenix. Phoenix is a framework, of course. It is just it's the trying to be Rails of the Elixir world. Of course, it uses Elixir somewhat competently in many cases, but it, generally speaking, presents a facade that you don't need to necessarily know Elixir. Certainly, that is the effect it has on a lot of people. I have seen people, for example, say you should not be writing your own gen servers. And for those who might not know, a gen server is a general concept for writing a process that runs on a thread in Erlang, right? I absolutely would say you need to know how to write a gen server. It is central to using Erlang and Elixir. The reason they need to know this is because that is how you effectively use the language, how you use this platform. Because otherwise you will build solutions that, well, they are distinctly worse than anything else. And you will not have an intuition for how anything executes. So everything in an Erlang system executes in a process. There's nothing in an Erlang system that executes outside of processes. There's no main process either. Everything is processes. These processes are just one thread and so on, like I said, right? That intuition to build that and how these work, realizing that, well, a lot of stuff is gen servers, knowing how those work and so on, is going to pay off big time. And yeah, that's what I would say, that to use this language to its actual potential, you will have to do that and so on. And I have seen this fail many times with learners where they expect to not do that. They expect to simply magic something into existence, but then you tell them, make a gen server, store this stuff in it. Now you can query that stuff whenever you want. And that's a very simple prospect for someone that knows that. But for someone who went into it saying, oh, I don't need to learn those things, now you're basically telling them to fuck off a little bit, right? And so I think it's important to kind of say that there is a host language here that you have to wrangle, because that's the case with PHP and Symfony, I'm assuming. Like, you're going to have to understand how PHP works here, because Symfony is not going to do everything you want it to.
Yeah, that's very, very similar to Ruby and Rails, actually. Because Rails makes everything so simple, you can go for a long time without actually understanding Ruby well. And you have the same problem where you kind of know Rails, you kind of don't really know Ruby, and you very often get confused because Ruby has so many small syntactic things that it takes a while to properly understand. For example, you can drop not semicolons, but curly braces when you're passing a hash as the last argument, but not always. And it got even more complicated with the newer version of Ruby, where they now have keyword arguments, and it clashes with those implicit hashes at the end.
Oh, yeah. You have these implicit * arguments in Ruby nowadays. So
yeah, something like that. And there's a big element of, Rails makes everything simpler. But if you don't know the language, occasionally you just don't understand the beginning and the end of the error message you're getting, because an experienced Ruby developer would see it immediately, but a non-experienced one would be, what's going on here?
Yeah. And this is when you learn via framework, this is always the risk. You're learning the framework, and the framework just makes tons of assumptions for you. It offloads the burden of responsibility a lot in a different way, where if you, for example, say, hey, I'm going to learn Ruby by writing a web server, there's no responsibility being offloaded here. It's you and the program. You're going to have to now parse text, make requests out of that text. You're going to have to send responses, and so on and so forth, right? In doing so, presumably, you will now understand rack, for example, or whatever. I don't know what's being used nowadays in Ruby, I'm sorry. But
it's still rack.
Yeah, so rack, for those who might not know, is basically a infrastructure for middleware, correct? Yeah. So a request will go through a series of these kinds of things and be modified and analyzed, and then you will, at the end, spit out some kind of response to the requester, let's say, right? The other side. And in building all of this, presumably, you could actually see, hey, I can make rack, for example, right? I am at a point where I can actually make rack now, for example. Maybe it's going to be a bad version of rack, but certainly I will understand rack more once I've done this, is kind of how I see it, right? And I don't know if this, because, of course, Vladо, you mentioned like this is what everyone says, and people already view you as this is just two old school kind of programmers or whatever, or old school people saying the same thing as everyone else. And I don't know if this is good advice, right? But I can tell you that it's my honest opinion, right? It's definitely, I want to say like I don't think it's useful to view it the other way, but it is mostly that I cannot envision that would be the case. I might be wrong. Absolutely, I might be wrong. But I think it is generally more useful to be able to build things than to know things. And because being able to build things implies knowledge of much more fundamental things, generally speaking. So building a web server, well, implies that you understand what HTTP is, you understand server and client infrastructure, and so on and so forth, right? Presumably, you will also encounter like, oh, I can service one person per time. How do I solve that? Well, let's learn, right? And all of these things, right? So, but knowing how to use Rails does not imply any of those things, right? It implies I know how to use Rails, right? And which is a useful skill to have. Don't get me wrong. Absolutely it is, right? But being able to build Rails, I think is more useful in the long run.
I have one more question, if I may. I served as a CTO for 10 years. And when you're a CTO in a relatively big company, usually a lot of people who are not tech people ask you, if I want to become a developer, which language should I use? Learn. And I always told them that the language is not that relevant. It's way more important. What would you like to do? And in a way, this reflects to my own past experience because I got involved with technology because I wanted to build websites. And I wanted to build websites because I was a founder of an RC channel. And at that point of time, each RC channel should have a website where you put all the members, etc. So for me, the goal was just to build a website. And I was not focused on, I want to be a web developer and then I should learn HTML and CSS at that point and PHP later. I really wanted to build a website. And based on your own experience, what is your view on that? Is that a good advice, or people really need to do a market research, which is the most desired language, which companies give the best compensation for that, and really focus on the grind to learning the language, or it should start with the passion and the goal, or a mixture? And I would really like to learn to Stefan to join after that too on this one.
Yeah, so this is obviously, it's one of the most difficult questions about learning to me, right? Because while I have opinions, I'm not entirely sure I have an answer that actually seems like it could be correct. Because in theory, asking someone what they want to do sounds like the most reasonable thing, right? Yeah. It sounds like, hey, there are different sides of programming, different languages are good at different things. We know this, because we're in this bubble of, knowing this, right? The problem there is that we presuppose that the learner has any idea of what they want to do.
Yeah.
And that is one of the most difficult things to actually...
I can agree that in a way, this is the most not fair part in my advice because, but still, for me, I knew what I wanted to do. So
I found what I love doing fairly early, namely servers. Right? Having a computer talk to another computer, when I learned how to do that, was a magical experience. Just saying, I can have a computer here that can talk to some other computer somewhere else, and that can actually be, I can make that happen. This was not possible before, and now it's possible. I can write a protocol that transfers a file from one computer to another, or I can implement someone else's protocol to do the same. I was more into actually implementing my own because it's more fun. But I found that fairly early because I found Beej's Guide to Network Programming, and that was sort of it, right? I knew this is the stuff. The stuff that no one can see that goes on behind the scenes is what I want to do, right? So back-end programming, basically, but I learned it from just making servers and so on. And so this was back in C++, obviously. But I think knowing what to do might be a poor motivator. And I've seen this happen with people who they come to me and they say, I want to learn programming. And I might have some canned answer for them, like, oh, well, Python is a language. It exists. You can write things in it. You can express logic in it. And I think it might, if you use these parts of it, you can learn how programming works, sort of, right? But that also feels like an exceedingly bad answer, right? Because it's not necessarily the case that you can't actually direct people enough with this either. I think the whole fundamental thing, maybe we need to be more honest about what people actually want to, because you mentioned market research, which is also, if you reach that point with someone, you ask like, okay, so do you want to just get a job or do you want to learn programming? Because these can mean different things, to be honest, right?
Yeah.
That's also difficult because, okay, what do you then recommend? It turns out in Stack Overflow surveys, Clojure is one of the best paid languages. Why is that? Well, it's not necessarily because Clojure is some magic sauce that, like, it has that mojo. You just make money. PHP has more dollars in it than Clojure, right? Certainly. So, but the reason is probably there's a large section of, let's say, old programmers that transition to Clojure at some point because of a perceived simplicity or something like this. They, for example, might have certain skills on the JVM that make it so that they can use Clojure effectively because they know all of the trapdoors anyway. They know how to use the Java interfaces from Clojure. A new learner will not know those things. They're certainly not going to get paid as much as those people. So even the market research is it's fraught with, pitfalls and stuff like this, right? So it's very, very difficult to say because I could say, I've made lots of money off of Erlang and Elixir. I've paid for 2 apartments with that money. But that doesn't mean someone can just say, I'm going to learn Elixir and then, go out there. It's very hard to find a job in certain circumstances with Elixir. You have to basically know people. I stumbled into it sort of like, here's the company using Erlang. I like Erlang.
My philosophy is that the tools and the money could not be the goal. The goal should be the passion because the passion will lead to excellence and excellence will lead to money after that. So this is my philosophy on that matter. So that's why I am advising people to find the passion, and after that, the tools will come up naturally. And if they have the right passion, the right mission, they will achieve excellence, and from that excellence, usually monetary success is inevitable at that point.
Yeah, this is kind of why I think the initial motivation might be a poor motivator, because the thing that actually gets people to stick with stuff, like I've had at this point, it's 3 or 4 friends who got into programming and they basically did not continue. I would say the initial motivation doesn't matter as much as the persistence, the stubbornness to not let the environment win in some ways. I'm sure you know this feeling of, I will not let this bug win today. I will just, even if, I might solve it tomorrow, but I'm working on this until I've done it.
I call this true grit. If you have a true grit, you will steamroll and you will sustain yourself.
And so I think that is maybe the best motivator. And then I also have this philosophy or principle or whatever that I've adopted from Stephen King, that I do, no matter what, no matter sickness or whatever it might be, I do a little bit of programming every day, regardless. It doesn't matter. We're talking outside of work, in work or whatever, right? I then later apply that to, even if I program for work, I always do side work as well. That is to always keep moving forward, right? Because once you teach yourself that no matter what, maybe I've had a rough day, right? Maybe my day was terrible and, it doesn't really matter what happened. Maybe I was robbed today or whatever it might be. Maybe I have the flu today, right? And it's hard to think. I will do a little bit of side programming every day regardless. Doesn't really matter. I have since extended this to doing research because the research is actually the most important part of some of these projects, generally speaking, right? So I don't necessarily write code literally every day nowadays. I do also research on, for example, lately I'm researching TLS because I'm trying to implement TLS. But, stuff like this, right? So that's a principle that I employ in order to keep momentum. Because you get momentum and then you keep it by just doing a little bit every day. Oftentimes, this a little bit turns into 2 or 3 hours because I realize, hey, I want to do this thing, right? And I'm not stopping after 30 minutes. I'm going for it, right? And so on. And I think that kind of mentality can be more valuable than some, because one of the hardest things for people is like coming up with projects. I find that this stops a lot of people. And they are unwilling to make projects that no one asked for. They are unwilling to make projects that are kind of silly and only exercise some concept, for example, right? And I would urge people to let go of that feeling. Because the truth is, even if you make something that people could conceivably want, most of them will not want it. This I consider just a fact of life. You make something that's super useful, no one will recognize it like at all. So drop that idea. Not everyone is going to have like products just blow up. It's fine. Make things because you want to learn, make things because you want them or whatever it might be. Even if you don't want them, just exercise some concept, whatever it might be, right? And so on. So I think that's more useful. Maybe the mental, the attitude towards things is maybe a bit more useful there.
Now, we do have this thing where we try to let the guests have the last words. We don't always succeed. We keep talking after them for some reason. But if you want to leave people who've listened to us for the last, let's say, 2.5 hours with one thought, which thought is it going to be?
It's going to be quite, let's say, it's an extensive thought. But I'll try to substantiate it so that, there's something to actually bite into for everyone here, right? I would suggest this to everyone listening, including, new, experienced, whoever might be listening. Because I know that this happens a lot in, every experience level, really. Constantly try to reevaluate what is real and what is not. And what I mean by that is there are very few things in a program that are actually real. We use proxies for everything, right? We use constructs that do certain things and so on, right? They accomplish something under the hood, right? So there's some code running at the end of the day that does something. All of that code is only in the service of really one thing and one thing only in every program. Every program is a transformation from something to something else to something else and so on. It's a series of transformations from one thing to another, right? A web server takes text, turns it into a request, which it then produces a response for, right? Very simple transformation and so on. One, start thinking more about the transformations. No matter who you are, you might be John Carmack, I don't care. You probably would do just with thinking more even about it, right? Of course, he's a god genius or whatever, but I bet even he sometimes gets lost in the weeds of, hey, what am I doing right now? Does it have anything to do with data transformation, right? Because we do things a lot of the time that have nothing to do with data transformation. We mandate rules about code that have nothing to do with writing data transformation in a clearer way. We have rules, in fact, in some code bases, in some communities, that make it harder to see what data transformation is going to happen. Find your center in this entire conversation, right? Because I promise you that there is a point where you will find that you can be maximally productive within this framework of thinking about data transformation, right? It might be, folds, reduces, maps, and so on. I'm not super concerned with that, right? But I promise you that it will pay off to think more about simply what data do we have in, what data do we have out, where do we go between that, what do we save from those transformations in order to do something more efficiently and so on. And that is what a program is. That's what all programs are. Almost no exception. I say almost because I can't guarantee. But I'm not 99% certain that that's what all programs are. That 1% is the almost, right? And so that's kind of what I want to leave people with. Think more about transformations and so on than, hey, everything has to be a class, my dude. No, sometimes it doesn't, and so on, right? So data transformation, most important thing.
Thank you.
Awesome. I think that was a good thought to end on.
Yeah.
Well, first episode in English, guys.
Yes. Not the last one, I hope.
Yeah, many more to come, I'm sure.
Many more to come. Okay.
Well, let's see.
Благодаря ви, че останахте до края с нас. __ е част от мрежата на Говори Интернет. Водещи бяхме аз, Владо и Стефан. Продуцент епизода беше Стефан Кънев, аудиоредактор и монтаж направи Антон Велев, музиката и корицата ни са от Тунко, а дизайнът ни от Иван Кинев. Ако искате ли да дадете обратна връзка, разбира се, в бележките на шоуто има връзка към формуляра ни за обратна връзка, а също така най-добрият начин е да отидете в нашия Discord сервер, където има специален канал, посветен на този подкаст, и там може да ни дадете някакви обратни връзки, впечатления, съвети, акъли или въобще каквото искате. Дискорд серверът ни се казва _. Ако искате да споделите любовта, идете ни напишете едно ревю в iTunes, рейтнете ни в Spotify или се абонирайте за нас там, къде си получавате подкастите. Това най-често е Spotify, iTunes или каквато и да е друга програма за слушане на подкасти. Ако искате да ни подкрепите, то идете в магазина на Говори Интернет. Той е на адрес shop.говори-интернет.com и там може да си купите някои от нашите тениски или въобще всякакъв мерчендайз от мрежата на Говори Интернет. Ако този подкаст не ви беше достатъчен, слушайте старите ми епизоди, или пък ако сте ги слушали вече, имаме една камара други подкасти, например подкастът Майка говори интернет, подкастът Транзистор, в който си говорим за джаджи, Дропичили, в който си говорим за храна, Първите говорят, в който си говорим за инвестиции, Естествен интелект, в който си говорим за подобряване на качеството на живота и психология, Говори артиста, в който си говорим за съвременно изкуство, и Ден, нашият всекидневен подкаст, който е новинарски. Благодаря ви, че останахте до тук. До нови срещи!